And then finally the second row, second column, 1, -4, 5, -2. Okay, so we're going to be using given matrices, and we're going to evaluate another expression. So here we're going to evaluate A times B minus C, where A is a 3 by 2 matrix and both B and C are 2 by 2 matrices. So let's look at what that looks like when we set that up. So here's A. That's our here's A. Here's our 3 by 2, and then here's B, and this is minus C. Okay, so we're following the same order of operations that we would do if we're just working with real numbers. So we work within the parentheses first. So we're going to subtract these two B and C matrices together first. And then we're going to multiply with A. So I'm just going to bring down matrix A. And this is where showing your work vertically, showing each step is very critical. Okay, so I'm going to change all my signs. So because it's subtraction, so that becomes a -2, that becomes a +4, -1, and +2. So 2 minus 2, that's going to give us 0. 1 plus 4, that's going to give me 5. -3 and -1 is -4, and 0 and 2 gives us 2. Now we're going to multiply these matrices together. I have a 3 by 2 and a 2 by 2. I can multiply the 3 by 2 with the 2 by 2 because both the number of columns and the number of rows match up. My end result should be a 3 by 2 matrix if we do this correctly. I'm going to cover up the second column in the second matrix, and I'm going to cover up the bottom 2 rows in the first matrix so that I'm only looking at the first row in the first matrix and the first column in the second matrix. We'll start off by multiplying 3 with 0, which gives us 0. Then -2 times 5 is -10. Now I'm going to cover up the bottom row and the top row so that we're focused on just the second row. And we're moving down vertically in our product matrix. So 0 times 0 is 0. 4 times 5 is 20. Now we'll look at only the bottom row. So -1 times 0 is 0. 5 times 5 is 25. Okay, now that we've done all the rows in the first matrix, we will do all the with the first column. We've done all the rows in the first matrix with the first column in the second matrix. Now we're going to do all the rows in the first matrix with the second column in the second matrix. So I'm going to cover up the bottom 2, and we start this process again, but with the second column. So 3 times -4 is -12. -2 plus 2 is -4. Then we cover up the top and bottom so that we are only looking at the second row. 0 times -4 is 0. 4 times 2 is 8. And then finally, we will look at just the bottom row. -1 times -4 is 4, and 5 times 2 is 10. Okay, so now I'm going to simplify what we have. -10, 20, 25, -16, 8, and 14. And it is a 3 by 2 matrix, just like we anticipated. So the last thing we want to look at is the properties of matrix multiplication. As you can see, the properties are more or less the same as far as if you were dealing with real numbers. You have the associative property where the grouping, if you're, of matrix multiplication, where the grouping doesn't matter. But notice that there is no commutative property. You can multiply a 3 by 2 matrix. You can multiply a 3 by 2 matrix with a 2 by 4 matrix, but if you were to flip them, you can't take that same 2 by 4 and multiply it by the 3 by 2. So like if this is A and this is B, you can multiply A with B, but you can't multiply B with A. So order does matter when multiplying with matrices. We have one thing called the left distributive property, where we distribute where the A is on the left, and we could take that matrix and multiply it with matrix A and C. And you can also distribute to the right, where let's say you have matrix C, and then you can distribute that to A and B. And then finally, we have the associative property of scalar multiplication, meaning you can multiply matrix A and B together first and then the scalar, or you can multiply the scalar with A first, then B, or you can multiply the scalar with B and then A. It all will give you the same result. Anyway, that is multiplying with matrices, and with some practice, you'll get pretty good at it. So, we've delved deeper into the matrix, and next time we're going to get into the thick of things. It'll be awesome. See you then.